Alright, so in this video we're going to introduce the other type of product that we're going to discuss. This is known as the cross product. So to define the cross product in R3, okay, let's say we have two vectors A and B, and in components A is A1i plus A2j plus A3k, B is B1i plus B2j plus B3k. And so we'll define the cross product of these two vectors, written A cross B, and note the notation here used to denote the cross product, right? We're using this cross, hence the name cross product. This is defined to be the following vector quantity. Okay, so it's A2b3 minus A3b2i minus A1b3 minus A3b1j plus A1b2 minus A2b1k. All right, so first, just to emphasize, when you take the cross product of two vectors, the result is a vector, okay? So for that reason, the cross product is oftentimes referred to as a vector product, right? Which, of course, is different than what we saw with the dot product. For the dot product, right, A dot B, the result was a scalar quantity. Here for the cross product, we get a vector as the output. Okay, now looking at this definition, you very well may wonder, why on earth would you want to define a cross product in this way, right? This seems like a bit of a formidable definition, okay? Well, we're going to get to why this is such a useful construct here through the next couple videos. First thing I want to say, though, along the lines of actually how to compute a cross product, is to say that while this definition is perfectly fine, okay, it's actually quite a bit easier to use determinants to compute cross products. There's far less to keep track of and to remember if you know how to compute a determinant. Okay, so first I want to just say a few things about what determinants are and how we can compute them, and then we'll go ahead and come back to this definition of the cross product and see how writing it this way using a determinant aligns with this expression you see up above. Okay, so let's first look at 2 by 2 determinants. Okay, so I have this 2 by 2 array of numbers. Okay, this is known as a matrix here, A, B, C, D. Now to take the determinant of this 2 by 2 matrix, okay, it's denoted using these vertical bars, right? Look like an absolute value there. So the 2 by 2 determinant of this matrix here is defined to be AD, so the product of the diagonal elements, minus BC, the product of the off-diagonal elements. Okay, so as an example here for the matrix 2, negative 4, 5, 3, the determinant is 2 times 3, which is 6, minus negative 4 times 5, and that comes out to be 26. All right, so now for a 3 by 3 determinant, okay, we can define it in terms of 2 by 2 determinants. Okay, so that works as follows. First, we note that there is a sign change as we expand the determinant, and here we're going to expand along the first row. Okay, now if you take linear algebra, where you're going to study determinants in a lot more detail, you'll see that you can actually expand determinants in multiple ways. Okay, but for this class, for our purposes, we will always expand along the first row. Okay, and there's a sign change here that we're going to see as we open this up. All right, so here's what we're going to do. To expand along the first row, I'm going to take this first entry A, and then I'm going to delete out the rest of column 1 and the rest of row 1, and that leaves me with this 2 by 2 matrix you see in purple. So I'm going to take A and I'm going to multiply it by this 2 by 2 determinant. Okay, now here's where the sign change comes in. Okay, so the coefficient here, right, is just A itself. So this positive here just says you just take A itself. Okay, now for the next term, what I'm going to do, I'm going to leave that in. I'm going to go ahead and move over to B, and I'm going to delete out the rest of row 1, and then I'm going to delete out the rest of column 2, and I'm going to multiply B and this 2 by 2 determinant in green. That's going to be right there. And notice there's a negative in front of the B. Right? You see that sign change. It's coming from right here. Okay, and then lastly, we'll go ahead and go to C, delete out the rest of row 1 and column 3, and I'm going to multiply C by this 2 by 2 determinant, right, that you see here in blue. Okay, and now to compute these 2 by 2 determinants, well, you just use the rule up above, and then you'll get your answer. So let's illustrate that with the following calculation. So I have this 3 by 3 matrix that I'm going to take the determinant of. So 2, negative 3, 1, 5, 0, 2, negative 4, 7, 3. So to open this up, I'm going to start at the 2, and the 2 will multiply this 2 by 2 determinant, right, 0, 2, 7, 3, that's obtained by deleting out the rest of column 1 and row 1. Okay, so that's this 2 by 2 determinant we're going to compute. Then I'm going to do what? Well, minus, because of this sign change I noted up above, a negative 3, and then that's going to multiply what 2 by 2 determinant? Well, I'm going to delete out the rest of column 2 and row 1, so I'm left with this determinant 5, 2, negative 4, 3. Okay, so I'm going to have to compute that, and then I'm going to do a plus 1, that's the last entry in row 1, and that's going to multiply the determinant I get by deleting out row 1 and column 3, so that's 5, 0, negative 4, 7. Okay, so now go ahead and compute each of these 2 by 2 determinants using the AD minus BC rule from above. So for this first determinant, I'm going to get 0 times 3 is 0, minus 7 times 2, right? So that's going to be a minus 14, and that minus 14 will multiply the 2. Then here I'm going to get a minus a negative 3, so that's plus 3. And then this determinant in green will be 15 minus a negative 8. So that's a positive 23. And then I get a plus 1 times this determinant in blue, that's 35 minus 0. So that's a plus 35, and that all comes out to be a 76. Okay, so now notice, going back up here to what I wrote down for this computation of the cross product, so A cross B, notice now the first row is made up of the standard basis vectors I, j, and k. Okay, so to expand this determinant, we do it just as we described down here, right? So we start with I, which I'm going to put out in front just because it's a vector here. And so what's the coefficient of I? Well, I find that by deleting out column 1 and row 1, and that's going to leave me with computing this 2 by 2 determinant here. So A2B3 minus A3B2. Oh, okay, that's exactly what I had up here. And then, due to the sign change, I have a minus, and then I'm looking at the J next, so that's right there. And then I delete out column 2 and row 1, and that leaves me with the determinant A1B3 minus A3B1, and that's exactly what I had up here. And then finally plus K, which is right here, and its coefficient is found by taking the 2 by 2 determinant obtained by deleting out row 1 and column 3. So A1B2 minus A2B1, and again that agrees with what I had in that above definition. All right, great. So now let's go ahead and look at an example. Okay, so I'm going to make a little space here. And so let's go ahead and compute this cross product. So let's say A is the vector 3i plus 2j minus k, and B is the vector negative I plus 2k. Okay, so to set up the determinant, you always have ijk for the first row. Then you have the components of the vector A, so that's 3, 2, negative 1. And then for the third row, you have the components of the vector B. So negative 1, 0 for the j component, because you don't see a j, and then a 2 from the k, right? So then you expand it just as we described. So for I, right, we're looking at the determinant 2, negative 1, 0, 2, right? So that's going to be what? 4 minus 0, so that's going to give us a 4i. Then we have minus, And for the coefficient of j, that's going to be the 2 by 2 determinant found by deleting column 2 and row 1. So 3, -1, -1, 2. That's right here. So careful with your negatives, right? We're going to get a 6 minus 1. So that's 5 just from the determinant, but then there's that negative in front. So we get a minus 5j. And then lastly, for k, well, the coefficient of k is the 2 by 2 determinant found by deleting out row 1 and column 3. So 3, 2, -1, 0. And computing that determinant, we get 0 minus a -2, so that's a plus 2k. So, right, again, we take the cross product to two vectors, and the result is a vector. Now, in the next video, we're going to go ahead and see why this is a useful thing to consider. All right, so I'll see you there. Thanks.